2025, or as we fondly call it, Nice TEAS Asia 2025. I am Ashi, and it's an absolute pleasure to moderate today's online session. This international conference is jointly organized by the Banking Academy of Vietnam, Hanoi, and Apex University, Jaipur, India, supported by Shree University College, Jaipur, and managed by KK Consultancy Services, India. This year, we received an overwhelming response with over 400 paper submissions from across the globe. And after filtering out AI generated and plagiarized content and a rigorous peer review process by an expert panel, only the top 80 papers were selected for presentation. Based on their performance and the recommendations of session chairs, these selected papers will be published by Springer Nature. Yesterday, on the 29th October, the day one of the conference, we had an incredible series of keynotes, paper presentations, award ceremony, and discussions that truly embodied the spirit of innovation and inclusivity offline in Vietnam. As we step into day two, we carry forward that same enthusiasm, ready to dive deeper into thought provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I am pleased to introduce our session chair for this segment, Ms. Neha Tiwari and Mr. Rakesh Roshan. Before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. First, each presenter has 7 to 8 minutes, so please try to stay within that time limit and try not to exceed it. Second, briefly cover your research content, objectives, methodology, key findings, and conclusion. Third, a short Q&A may follow your talk of 1 to 2 minutes, so please keep the responses brief and focused. Fourth, keep your mic muted when you're not speaking. Fifth, stay for the full session to support other presenters as well. Now, with the kind permission of our session chair, we shall now proceed with the paper presentations. I would like to invite our first presenter of the day, presenting the paper titled Integration of NMT into Smart Road Infrastructure under the code 184. I request Ms. Bhavna Chahar to please take the virtual stage and begin the presentation. Over to you.
Thank you, ma'am. Just give me a few minutes. Hello, am I audible?
Yes.
Okay, thank you. I'll begin now. The paper ID 184 is titled Integration of NMT in Smart Road Infrastructure. Beginning with the problem statement, the critical
Please,
juncture of
excuse me,
urban.
excuse me. Please, who are giving the presentation, switch on your video. Okay.
Okay, sir.
Yeah.
All right.
Thank you. Okay, you can continue.
Beginning with the problem statement, India's rapid urbanization has strained its road networks, resulting in severe congestion, high accident rates, and increased pollution in cities. Recently, Bangalore was ranked among the world's most congested cities, with commuters spending approximately 152 hours a year stuck in traffic. In 2022 alone, India recorded on average 462 deaths every single day. Approximately one-third of these fatalities occur in urban areas where NMT, that is, non-motorized transport users, are often the most vulnerable. The need for smart road infrastructure. Traditional approaches of simply building more roads are very slow, expensive, and constrained by land and environmental limits. An estimated 70 to 80% of the urban infrastructure required by 2050 has yet to be built, presenting an opportunity to design smarter roads that preserve NMT users' safety. Several flagship programs, such as the Smart Cities Mission, that is the SCM, have integrated smart traffic management systems to improve mobility and promote the use of NMT. Moving on to the foundation technologies and pilot projects, key enablers. Smart infrastructure relies on pervasive sensing, robust communication, advanced analytics, and integrated platforms such as cloud services, digital twins, etc. A systematic review of AI and the Internet of Things enhanced traffic signal systems found reductions of up to 30% in average traffic delays. Indian pilots and outcomes. The Bangalore Adaptive Traffic Control Systems, that is the BATCS, used AI and CCTV plus edge computing and reportedly has achieved approximately a 30% reduction in delays. The citywide adaptive system synchronizes 165 intersections. Similarly, in Nagpur, the iRaste has a road safety pilot program combined with AI, IoT, and computer vision to identify the accident's gray spots. Similarly, in Kerala, they have the Kerala Enforcement that deployed 722 AI cameras with a targeted 50% accident reduction. Moving on to the framework solution provided, Layer 1 Sensing. The surveillance cameras, that is the CCTVs and interactions, track NMT traffic in real time and detect incidents. Environmental sensors monitor weather conditions to issue warnings and in extreme conditions potentially restrict the NMT movement. Layer 2 talks about the communication and network. Optical fiber backbone along major road provides high bandwidth, reliability, low latency data transfer. 5G wireless networks are expected to significantly enhance the communication, enabling the exchange of low latency safety messages. The edge computing nodes provide data locally, that is through image processing at locations like traffic signals, controllers to reduce latency. The third layer talks about intelligence. Traffic Management Center, that is TMC or the control room, centralized or regional integrated command centers display dashboards of real-time traffic conditions, maps, and incident alerts for operations. Artificial intelligence and analytics. AI algorithms use predictive analytics to forecast congestions, build up and suggestive preemptive measures. Computer vision detects specific events such as a person riding without a helmet or a car parked illegally. Cloud and data lakes. Data is stored on cloud servers for historical reference and long-term planning. Digital twin models. Virtual replicas of road systems fed by real data allow planners to simulate infrastructure changes or new traffic schemes. For example, the new one-way schemes before physical deployment. Key applications for smart mobility and NMT safety. The Adaptive Traffic Signal Control, that is the ATCS. Signal timings are continuously optimized based on sensor inputs to reduce waiting time and allow green waves. Smart enforcement. AI-powered cameras and ANPR systems automate the detection of violations, including speeding, red light jumping, helmet compliance, illegal parking, and the encroachment on the NMT pathways. Delhi's upcoming AI-based system is designed to detect 19 types of violations. Incident detection and management, that is AID, automatic detection of crashes or breakdowns via CCTV generates immediate alerts and displays warnings on variable message signs, drastically reducing incident service time. Public transport prioritization. Smart signals can detect approaching buses and give them priority. System data can prioritize NMT usage at urban hotspots for multimodal optimization. Sustainable transport integration. Smart infrastructure supports NMT by incorporating pedestrian and cyclist
Can you
sensors at crossing to enhance safety.
can you show any results or anything is there, your diagrams or any architecture framework?
So this is just a proposal. It's not a primary based data, hence there is no graphical data.
Okay. Any results or any conclusion type of
No, sir, not that at the moment.
okay. This is literature review paper.
Uh,
What papers you included? Here it is
it's a
your
theoretical conceptual paper based on the secondary data, that is the government reports.
okay. What are the future directions for this whatever you done this research article?
So the title is NMT, that is the non-motorized transportation. So here the future recommendations is that
Just you
there still needs
go
to
to
be.
the okay. Just you go to the title because I joined at least 2 minutes late. I think that's
Okay, sir.
title. Yes.
The title, sir. Yeah, sir. Integration of NMT in smart road infrastructure.
Okay. So what do here?
The NMT stands for non-motorized transport. That includes anything human powered, from walking, cycling, anything that is non-motorized.
Okay, smart road infrastructure. That means you are telling about the vehicles and all vehicles connection.
Yes, how there should be the integration, because right now for the smart road infrastructure, the inclusion of NMT is not there. So the proposal here is to integrate NMT in the smart road infrastructure for future. Yes, I have stated. Yes, sir. The
Okay.
development of low-cost sensor hardware suitable for developing cities.
Okay. Any question from other members?
I just have one suggestion. I hope you can hear me.
Uh, yes, ma'am.
All right. So even if it is a proposal, the conclusion should be clearly stated in it, right? It's a review paper, as you said. So
Yes,
even
ma'am.
if it is a review work, it should give certain impact of impact in the sense of the work to be taken up, right? If you want
Okay,
to
ma'am. This will
continue
definitely
the
be
work
kept in
as
mind.
a research work, and if you really think the paper should you know be a kind of contribution to others, the conclusions should be clearly stated. Thank you.
Sure, ma'am. I'll definitely keep that in mind. Thank you so much.
Thank you so much, Ms. Ariha, for your insightful and well articulated presentation.
Thank you.
If there are no further questions from the audience or the session chair, I would like to invite our second presenter for the day, presenting the paper titled Future Trajectory Prediction of the Vehicles Using Time Series Forecasting Algorithm under the code 419. Um, I request Mr. Kalyana Krishna to please take the virtual stage and begin their presentation. Over to you.
So I'm not liking Abhishek will take this. Sorry.
Couldn't hear you properly. Can you please come again? Can we see the next presentation, please?
Since Mr. Kalyan Krishna is facing some technical issues, I would now like to call the next presenter. Uh, Under the title of AHIPAA, Compliant Big Data Architecture for Real-Time Health Benefits Navigation Using Conversational AI, under the code 432. So please begin with your presentation. Thank you.
Yeah, can you hear me? Can you see my screen? Can you hear me? Hello?
Yes, we can.
Okay. So I'm gonna present it. So it's okay. It's okay. Okay. So my presentation is about HIPAA compliant big data architecture for real-time health benefits using conversational AI. So, what is meant by HIPAA? And my name is Nagasai Mrinal, and we have co-authors Vallikrant, Sai Rupesh, and Abhishek Dikshit. So, I'm from Humana. So, an health insurance company, mainly based on technology. So, HIPAA is nothing but health insurance priority authorizations. So, where it has a standard that, that we cannot reveal the patient's information when accessing any healthcare data. So we are proposing a big data architecture. So for a chatbot system, so using a conversational AI. So what does it mean? Like on a basis, usually when we go to an health insurance agent, when we want to know about the information of the service that we have received from the provider, like the doctor. So and we wanted to know how much does the claim has been used. So we use generally use the chatbot systems, or we usually call center folks to get some information. But in the traditional systems, it would take a lot of time. Like generally, it would take like a 20 to 25 minutes to get the concerned folks into the team and ask about the information. So it would take a lots of time and it's a lot of waste. So during with this research, we are trying to reduce that latency time and also getting the right information for the people. So my abstract represents about the critical bottleneck in the US healthcare system. With the traditional system, approximately 496 billion is in the dollar is an annual waste. This research presents a novel driven big data driven conversational AI designed for real-time health insurance benefits while maintaining the HIPAA compliance, as I mentioned before. So the system integrated, what we have used is LLM, natural LLM processing capabilities with the big data analytics. And we have used data layer architecture in order to implement the security protocol access through the overall the crowd infrastructure. So the three-level design incorporates GPT-4 API conversational interactions and Apache Spark and AWS CMF for processing around 10 million of claims per hour. That is also stored securely on the Amazon data storage. Through extensive simulations and the data, we were able to achieve like 92.4 accuracy with a median response time of 1.2 seconds when compared to 5 minutes or 8 minutes. So this overall represents the improvement in the traditional call center interactions. So what is the problem statement? So what are we facing in the traditional systems, in the healthcare systems? Information fragmentation. So the information is fragmented about different systems, which is typically hard to get over the call and try to tell to the patient in a layman terms. Policy complexity, and it has different standards like EDA transactions with the different structures and scalability limitations. It's all about traditional call center approaches and also compliance requirements, HIPAA regulations, because the information can be seen by everyone, it can be misused everywhere. What are the research objectives? We are developing a scalable system which helps in real time navigations, which is real time with the latency of 1.2 seconds. And we have used NLP model, like our machine learning model, specifically tailored for insurance terminology. And we have used a framework for measuring accuracy, speed, and compliance. And we have demonstrated significant improvements in administrative efficiency while maintaining the highest standard of data security. As I mentioned, there is a three-tier system. The first layer is a data storage layer, where we store in the Amazon RDS system with the encrypted from end to end. And S3 buckets for policy documents for lifecycle management. It acts like a constitution for the whole process. And Amazon trial for comprehensive audit trails. And for the data layer, AI and data layer, the engine where the AI, we have used the GPT-4 implementation for specialized prompts. So, for example, I've taken an MRI scan, and that would be, or I would like to know the cost for the after the co-payment has been achieved. So this GPT-4 implementation with specialized prompts go to that specific S3 bucket and try to get that information. And we have used like Apache Spark processing over 10 million claims per hour. It can be real-time tool when it can be more than 10 millions. And user interface, we have used React.js plus Node.js, and offline inquiry caching, we have used React. And we also used AWS transcribe integration, enabling voice to text conversation. This is just a POC. It's kind of a research that is being implemented. For the dataset preparation, we have used Kaggle, which is open, and we have used comprehensive dataset of insurance claims of 127K, and we have used it. We have a 45K transcripts and a policy document of 890 and a prior authorization. Even though this is like a HIPAA standard, we have used dummy data to for the training, and we have made sure that PHI are also taken care of with some privacy. And we have extracted some structured information into PDF data for analysis. While making sure the security is also important, we have used HIPAA compliance at every stage, because that acts as a compliance measure and their validation. And audit logging, we have used a different AWS tools for activity tracking and response limiting. And access control, we have used role-based access with the MFA. So everyone the user has to be into the system first, so that in order to interact with the chatbot. So we have used different security protocols along with this big data model. We have integrated the security network segmentation with the DDoS protection with the AWS Shield, and regular security assessments has been implemented. So the results has been embedded into a dashboard, AWS SageMaker and everything. So for the detectable information, we have 94.1 information for specialist coverage, 89.5 coverage. All these information in a layman terms, like if I'm a person where I took some, I went to a procedure and I want to know about what are my prescription drugs, what is the cost. So the chatbot goes into the system. It will be able to real time, and you would be able to say so and so person has been covered with 80% of the prescription drugs, and 20% has been went to the co-payment. And if I want to see what are the eligibility benefits that has been encoded with this insurance premium, the chatbot would be able to give me everything in a prompt, rather than like in traditional systems. I would wait for 20 minutes to get that response. And the performance benchmarking is like we have a throughput of 10K concurrent users with the median response time of 1.2 seconds. And when you see the comparison with the traditional models, it's like 8.5 minutes. This is the facts, and that has been taken from various sources in the internet. And the simulation, like we have taken few feedbacks, and we have got like majority of percentages. And economic impact analysis. How does it help in the projected savings of the insurance companies? We have saved like if it is fully implemented, we could save like 2.3 million of administrative cost savings and 40% of call center cost reduction, and the rate of investment would be more than 100%. The current limitations. It's not current limitations only supported to English, and it can be supported with multilingual support, including Spanish and Chinese, and with language models. And a policy update latency is 24 to 48 for incorporating policy changes. But with the advanced capabilities, including Epic and MyChat, these are the internal tools that everyone uses on a daily basis for looking into their information. With the integration of these APIs, with the expose of those APIs in a secured mesh fashion, we will be able to get the real-time information in seconds. And the current limitations are complex handling queries with human escalation of approximately 8% of the queries. Even though it can produce like a real time, it still needs some human interaction, because approximately only 8% of the queries have been achieved. Still, this is in the research phase. Integration complexity requires significant effort to integrate with existing healthcare system. The healthcare systems are everywhere, and it's very difficult to integrate into the existing systems, because there are so many standards and HIPAA compliance structures that needs to be talked about, and that has to be and we need to implement in such a way that there are no disadvantages in integrating to that systems. Conclusions. It's a conversational AI framework specifically defined for insurance benefits. Comprehensive benchmarking demonstrates significant improvements in accuracy, speed, and user satisfaction. And open source framework enabling broader adoption of secure healthcare AI technologies. And these are the metrics which we have shown earlier. And thank you, and I'm open for questions.
Where did you get the data from?
Kaggle. Yeah.
And what's the size of that?
I don't have it on top of my head. It's pretty big data, like around 2 GB of data, I guess.
Because that changed the entire equation, right?
Yeah, exactly. It's just a simulation
73%.
purposes. So pretty much.
Yeah, even after that, like it's quite a big claim to achieve
Right.
573% overall improvement, you know.
Yes. Yes.
So, do you have some research center, or have you thought of, going for some patent of your work?
Not yet. Not yet. So this is just a simulation we have tried in a small fashion. So we'll try that.
Yeah, but even after that, the results are, I would say they are very outrageous.
Yeah.
This is the word I get it at this moment.
Yeah.
Can you come to the slide where you use the tools of compare for comparison? Okay,
I've
anyway,
not
drop it.
included. I've not
You just tell
included all.
me.
No, I've not included all the tools for the backend purposes. We have used React plus Node.js, and
No, we do
for
have to use all the tools available.
yeah.
The only thing is that to ask you why you chose those particular tools for your work.
So the main concept is to use AWS. So that's the main reason. So because of this cloud infrastructure and the availability of the purpose, and for a
No, but the comparison has to be either between two or, three, four tools together that you've taken, if I remember, if I'm not mistaken,
true,
right?
if I
So,
so there are different options. So if I take a Azure, if the data availability of the tool is limited,
no, you're
then
not getting the
also
question.
yeah.
It's about selection of tools, why you selected those tools, whatever tools you've, selected for your work.
Mhm.
Why you choose that?
Uh, we have discussed and we have seen the limitations in the internet and
There are certain parameters, there are some similarities.
true,
Based on those grounds, we make the selection for the tools, right?
true.
So I could not see it anywhere. So if
Okay,
you have it on your mind, please include it in your
sure,
presentations next time onwards.
sure,
Thank
sure.
you.
Definitely. Yeah, definitely. Can I get a screenshot of this one? So maybe
Feel free.
sorry.
Any other questions, sir?
You can if you want to.
Okay. Thanks. Thanks. Okay. Thank you.
Thank you so much, sir, for your presentation.
No problem.
Now I would like to invite our fourth presenter for the day, presenting the paper titled Disease and Identification of Groundnut Leaves by Deep Learning Technology under the code 391. I would now like to invite
Just minute,
Mr.
Shiva.
Nikhil to please take over the stage and continue with the presentation. Thank you.
Yes, I am audible, ma'am. I'm audible. Good afternoon. I'm audible. Good afternoon, sir. Good afternoon, ma'am. My name is Hemant Mittal, in assistant professor in JCRC Foundation College in Jaipur, Rajasthan. And my co-authors is Miss Megha Rathod, Miss Apurva Joshi, Mr. Divyans Devani, Miss Avilasha, and Mr. Nikhil Vijay. My research topic is identification of disease and grounded leaves using the deep learning models. Deep learning models. Deep learning use the different techniques like the RNN and CNN, convolutional neural network, and recurrent neural network. Now the start my presentations. Now the start in abstract. Ground-end protection is the vital to Indian agriculture. Manual disease identification to the error-prone and costly. This study used the deep learning models. Three models use the BGG16, AlexaNet, ResNet 50 to automatically detect the ground and leaf diseases. Three diseases to identify the leaf diseases: early leaf diseases, late leaf spore, rust and leaf blight, and Tika diseases. ResNet achieved the highest accuracy, 82.30% real-time dataset collected from the Dungarpur Agriculture Research Center, Jaipur. Farmer to spend a lot of time mainly managing disease. There identify the disease using the make, eye, and results in error to identify the disease. The development of agriculture technology sustainability aids in the automatic detection to the photogenic organisms in the leaves. Now the second slide, introductions. India is the second largest producer to grounded globally. Major grounded growing states, Gujarat, Andhra Pradesh, Rajasthan, etc. Common fungal diseases, early leaf spot, late leaf spot, rust spot need to the automatic disease detections to improve the yield and reduce the losses. In order to develop an automated plant disease detections diagnosis system, it transferred learning models, BAS trained the models and testing the models to assess the bird using simple images, both healthy and diseased plant leaves. Now the research and objects, these techniques use the models in the three models in deep learnings, CNN and RNN. CNN use the deep fake detections using the image classification and different diseases to identification in the leaves. And recurrent neural network use the filtering models in the leaves nodes. Now the research object and scopes objective to develop the automated system to identify the ground and leaf diseases using the transfer learning. Scope identify the three common diseases, pillars and healthy leaves using the real-time argument datasets. Compare models performance BGG16, AlexaNet and ResNet 50. BGG16 use the problems to identify the three different diseases to slower comparison to ResNet 50. ResNet 50 to identify the faster and more efficiency and accuracy to check the diseases, to identify the filters model, to identify the solve the problems and different phases, different images and different phases to identify the deep learning models. The following three fundamental CNN architecture were put to test in the study investigation to identify the plant disease and photographs leaves Alexa, ResNet 50, VGC16. Now the Google Colab deep learning computational framework, which employ the Python programming language, use to create models in their training and testing procedures. Importance of the projects, reduce the deficiency on manual inspections, early disease detections, better crop management, support farmers with automatic remedies, enhance agriculture productivity using artificial intelligence, help the early detections of disease in ground and leaves, increase the crop yields and reduce the losses, save the time cost using the automatic deep learning models, reduce the deficiency on expert and manual inspections, help the farmers take quick and accurate decisions, promote the smart and modern farming techniques. Reason for the choosing the topic disease identification ground and leaves by the deep learning techniques. Ground and are the important food and case crop the many farmers. Crop disease causes major loss in the yield and income. Farmer often face difficulty identify the disease early stage, manually detections, time consuming, costly, and not always accurate. Deep learning provide the fast, accurate, and automatic disease detections and using the deep learning techniques. These topics support the digital agriculture, smart farming innovations. It helps improve the food security, farmer livelihood, growing the need AI-based solution in agriculture sectors. Then propose the solution, use the transfer learning, pre-trained models, phases, image collection, pre-processing, augmentation, labeling, and models training, three models using BGG16, AlexaNet, and ResNet 50. Then architectures, data collection, primary and secondary, pre-processing, augmentation, model training with transfer learning, classification, diagnosis, and remedy suggestions. Now the data collection is smartphone, Kaggle, Google Colab, leaf images. Pre-processing, open CBI, and augmentation, clean the image. And models, BGG16, ResNet 50, deep features. Output CNN classified diseases labels, accuracy 97%, verify the results. Technology use the programming language Python for framework TensorFlow, Keras, Google Colab, Keras, Platform was Google Colab, models BG16, AlexaNet, TestNet, Optimizer ADAM, dataset 313 images, 4 categories. Then methodology use the first methodology use the data collection, pre-processing, augmentation, model training, and evaluation. Evaluation to identify the accuracy, losses, and to identify the prediction value. Then methodology diagram, data collection, data pre-processing, modeling training, model training, testing, model evaluation, and disease identification and classification methods. Now the results apply the model accuracy, BGG16 AlexaNet, test model ResNet to 82.30% accuracy, comparisons BGG16 70.19%, AlexaNet 81.30%, lowest cost BGG16 1.528%. To BGG16 and AlexaNet to difference BGG16 to identify the slower but layer to layer disease to identify the process, and AlexaNet and ResNet to identify the shortcut terms use the faster and BGV16. AlexaNet and models accuracy, train models and testing models, half 60 to 40% ratio. 60% data is training model and 40% data is testing models. Then accuracy to identify the 4 process model, prediction, accuracy, recall, and F1 score. Then future research, increase the data size using the gain or more field data, test more advanced models, efficiency, regions, transformers, develop the mobile applications, real-time detections, more diseases and different crop types use the to disease the identify. Conclusion, deep learning models can effectively identify the ground and leaf diseases. ResNet perform the best among the model testing. The system can assist a farmer in timely intervention and sustainable farming. Thank you. Now you reach.
Not any question from my end.
Okay. Thank you, ma'am.
Thank you so much.
Thank you, ma'am. Thank you. Most welcome.
Thank you so much, sir. Now I would like to call our 5th presenter for the day, presenting the paper titled Roles of Technology in Disease Detection under the Code 409. I would now request Mrs. Apurva Joshi to please take over the stage and proceed with the next paper. Thank you.
Good afternoon, everyone. Am I audible to you all?
Yes, you're audible.
Okay, so I've shared my PPT. Is it visible?
Yes, it is visible.
All right. So good afternoon, everyone. I'm here to present our paper titled Role of Technology in Disease Detection. So it is authored by me, Apurva Joshi, and my co-authors are Archana Dubey, Pritika, Mr. Hemant Mittal, Ms. Abhilasha, and Ms. Girija Lavanya. So basically, we know that agriculture remains a key income source for developing nations like India, but there are so many issues associated with it, such as crop diseases that greatly reduce the yield and the farmer income and food security. So basically, this study is focused on certain oil seed crops such as peanut, mustard, and soybean. So these kind of crops often suffer some diseases such as rust, mildew, and blight. So basically, the goal of this paper is to use machine learning, particularly some pre-trained models such as VGG16 and ResNet 50 to detect the diseases so that we can early detect those diseases, and we will take suitable remedies accordingly so that we can help the farmers minimize the losses and improve their productivity. So
join करो ना, presentation चल रहा है ना.
So we are going to move on to the literature review. So I have considered various papers, around 40 to 50 papers for this particular paper. And many researchers have applied some convolutional neural networks such as RCNN, ResNet, MobileNet V2. But obviously their accuracy was not up to date. That's why we had to write this paper. So the accuracy has quite a range. So we will just accommodate all the technologies such that we can reliably, this research can be reliable for this particular purpose. So we have taken certain data sets for this. The data set which was previously covered by these researchers was Plant Village. So we have also taken that data set. Along with it, we have taken 2 or 3 more data sets. So the tools and technologies that we have used here is TensorFlow, PyTorch, Keras, OpenCV, and Caffe. And if we talk about TensorFlow, it was used to provide the flexibility and to actually support the concept of CNN, RNN, and GAN architectures. Then we have Caffe. This technology provided fast GPU-based image classification, because obviously we are dealing with the diseases in the crop. So we need some images of these crops. So this is a GPU-based image classification. We also used Keras here, and Keras simplifies CNN and RNN building. Among the pre-trained models, we have used VGG16, which is a 16-layer CNN, and it has 138 million parameters. So obviously it's a grand range, and we can actually perform the training and testing with more efficient manner using this kind of background. We have also used ResNet 50, which is a 50-layer deep network that solves the vanishing gradient problem. If we talk about the data sets that we have used here, so these 2 big data sets we have used here. The first data set is about groundnut leaves, which was taken from Kaggle, but the second data set was taken from UCI repository. In groundnut leaves data set, it is used for basically leaf count and what is the severity of any disease and how we can reduce it. And if we talk about the other data set, it included the training and testing data in over 35 categories. So basically all the researchers have used only 15 classes till now, but we have expanded it and we have numerically encoded it. So these are some data sets that we have used here. If we talk about methodology, then first of all, we have captured some high quality images of those leaves. We have taken both kind of leaves, such as healthy leaves as well as diseased leaves, and using some DSLR camera. And then we have performed the training, testing, and validation. The second step was image augmentation and pre-processing. Then we have applied the feature extraction techniques, and we have used some pre-trained models, as I have discussed earlier also. After that, we perform parameter optimization, and finally, we obtain a model which is very fast and cost effective, and it will suggest us with the remedies for those diseased leaves. So this is the extended version of that methodology. We will input healthy and infected images, then perform image augmentation, pre-processing, feature extraction, training and testing and validation, following by classification using certain models. If accuracy is not good, then obviously we will perform the parameter optimization once again. And then if it is good, in that case, we will create the model for disease identification by inputting new images for classification for testing purpose, and identify the disease accordingly and providing the remedies for that particular disease. So these are the 7 phases in which we will work: image collection, image augmentation, in which we will rotate, flip, and see what are the results now. So we will try to change the image we'll be taking them from different angles, and we will adjust the contrast and make a necessary adjustment. And using every kind of image, we can perform image augmentation. Then we pre-processed it and resized it. Normalization we will perform in this phase. Then in next phase, we will extract certain features. So on the basis of textures, shape, and color, we will actually perform this feature extraction. Then we will train our model and do the classification using the deep learning models such as VGG16 and ResNet 50. And we will train the model, we will label it, we will perform the testing, and validation on those models. And finally, we will evaluate the model performance, and then we will deploy it. If accuracy is better, then we can deploy it and optimize it. So these are some of the steps that we have followed in this research. And in results, we have obtained the results for different kind of plantation. For example, for sunflower diseases, the problems that we faced was about leaf blight, was rust or head rot, powdery mildew, and basal rot. So these were certain problems. So with leaf blight, we have observed the dark brown lessons with golden halos. Leaves were dry and fall. So these are the conditions for leaf blight. Similarly, for rust, we have rusty pustules on leaves, and it worsens at the temperature between 25 to 30 degree. In heat rot, we have water-soaked black lessons. In powdery mildew, we have patches on older leaves. And in basal rot, it appears around 40 days after sowing. So also, in case of groundnut diseases, we have three kind of diseases that we have observed: the ticka leaf spots, the rust, and root rot. So rust was common in all the three cases. So we have taken that into account. And in ticka leaf spots, we have actually seen that the yield was reduced, the nut quality was reduced. In rust, we have seen that severe infection were caused to the seeds. There was root rot in which the leaves drooped and the plant was dead in no time. And in mustard diseases, we have alternaria blight, we have white rust, downy mildew, powdery mildew, and bacterial blight. So these are some of the problems that we faced. But when we performed the technology that I have just discussed with you, we got this model performance overall. So we can see here that overall accuracy actually varies crop wise also, on the basis of what combination of model and optimizer we take. So you can see here clearly in table number 4, I have shown that if we have taken groundnut and we use the model VGG16 plus Adam, what is the accuracy? It is 62% only, right? But if we take some other model, we can see here there are certain models in which the accuracy is 75%. If we consider table number 3, so in table 3, if we use the optimizer SGD, which is very common, and along with it, if we use the model LXNet and SGD, then we are obtaining the accuracy of 75%. So this is how our accuracy increased with different kind of combinations that we have taken. So basically, oil seeds are very important for agriculture, and groundnut is the major oil seed. Mustard also we used like in our day-to-day life. Sunflower is an important seed. So it's very important that these seeds and these leaves, these plants should be disease-free, and it's better that we can predict them if what kind of probability they have to get the disease, and how what remedies we can take actually to make them stay away from those diseases. So this is the conclusion of this paper. And in future, we can increase the area. For example, we can cover some other parts of the country. We can increase the area output and yield. We can expand the cultivation data, that we can take it from northeastern or southern regions. We can develop some climate resilient oilseed varieties accordingly. And we can promote sustainable agriculture so that we can improve the productivity. So this is the future scope of this paper. These are some of the references that I have considered. So these are the references. Thank you. Any queries from your end?
Apurva, what's the latest year of papers which you've included for your reference?
Latest I have taken from 2025, the paper number 8. Can you see those slides?
No, we cannot see the slide, but
Okay,
yes, that was, I think, the only paper which you've included from 25. Because
no,
I
have taken some more. The 10th one, the 11th one.
the
So these
reason of
blogs I have
asking this is
considered. These
that
are not the papers, these are the blogs. that I've
Yeah,
come.
because I have seen a lot of similar work
Mhm.
done for flowers and other plant species also. So I'm
Yes.
still not able to comprehend the contribution of your work in this regard. So
Actually, ma'am,
it's just a suggestion you go through the research papers once again extensively so that you can come up with some novelty in your work, right?
okay, ma'am, sure,
Yeah.
sure.
Thank you.
Thank you, ma'am. Any more queries? So I'll take your leave then. Thank you.
Thank you so much, ma'am. I would now like to invite our last presenter for the day, presenting the paper titled Classification Based Machine Learning Model Driven Student Performance Evaluation under the code 371. I would now like to invite Mr. Sudipta Ghosh to please take the virtual stage and begin their presentation. Thank you.
Hello, am I audible?
Yes, you are audible.
Just a moment. Is it visible, the PPT?
Yes, it is.
Okay. Okay. Good afternoon, everyone. My research topic is based on, okay, sorry. My research topic is based on student performance evaluation based on classification-based machine learning. And this is authored by me and Dr. Shamsudra Gupta. So, um, the key idea of this research is to forecast student performance and determining whether they will succeed or fail by utilizing machine learning techniques with reasonable accuracy. So, predicting student performance assists in estimating students' grade or likelihood of success or failure through the use of machine learning. So, just a minute. Sorry. So the main goal is to identify at-risk students early and provide personalized support to improve their learning outcomes. And this approach support teachers like to monitor and assist struggling students and institutions to plan better strategies and resources and policymakers to make data-driven decisions for educational improvement. And this research will identify children who are at risk of low performance based on a multiple factors such as academic, like study time, or want to pursue higher education or not, or educational support by their family, and social, like relationship with the family, free time after their school or institution, number of absences in the school, and also parental and family background or demographics like age, mother education, father education, mother's occupation, father's occupation. Okay, so, and the next slide is about, okay, just a minute. So the abstract lies between some key points, like data-driven strategies are used to forecast student performance, which helps to evaluate learning outcomes and strengthen the education system. And machine learning models like logistic regression, k-nearest neighbor, decision trees, random forest, and support vector machine or neighbors are used to analyze student data and predict results. And here the result shows that the proposed model outperforms the existing approaches and in case of prediction accuracy. And the insights generated from this prediction enable educators to implement timely intervention and personalized learning and enhance overall academic success. So my problem statement is that many students struggle academically due to their social and some of social or behavioral factors or like some academic factor, as I already said in the introduction section. So traditional evaluation methods fail to identify that at-risk student early. So there is a need for data-driven system that can accurately predict student performance and provide the early intervention so that we can better personalize them or guide them properly. So proposed solution. So first is the problem definition. Problem definition means it predict the student academic performance, and the outcome types is like classification type, like is they are going to pass or fail, this kind of. And next is the dataset collection. So collect the this I have collect this dataset from the Kaggle, and in this dataset there have some type of academic record and demographic record. Academic record like attendance, their internal marks, exam scores, and demographic record like parental and family background, so their family income. Next is the data processing. In case of data processing, the first step should be the data cleaning. There may be just just a minute. Okay, sorry. You're right. Just a minute, my laptop has been charging. Okay. Am I audible?
Yes, sir.
Okay. Sorry, it has been low chat, so okay. So the second is the dataset collection. Within the dataset collection, there are some data cleaning step. Like data cleaning means there may be some type of missing data or null value, or there may be some blank data. So we have to replace the data so that we can properly work on the dataset. And the next is data processing. Data processing stage, we done some kind of transformation like using one hot encoding level encoder. Then you have to develop the model, like the algorithm we are using, for example, knn, support vector machine, neighbors, etc. Then we have to find out that which model is going to perform well. Like we have to evaluate the matrices like precision, recall, accuracy, this kind of thing by using the confusion matrix, and then we can deploy it to the solution. We can use some kind of web-based framework, like maybe it may be Django or Flux, so that we can deploy it in a platform where we can use for the human being purpose in real life. So the next is the objective. So the primary goal of predicting the student performance is to estimate students' academic result through the data-driven methods, and it aims to identify the students or the kids who may struggle academically ahead of time. There are some methodology given. One is data collection. Next is data collection means I have collected this data from the Kaggle dataset, and I have used to see it takes like it is of 40 KB kilobyte. And the next is data pre-processing and data cleaning state. In data pre-processing state,
Can you
like
please directly come to your work part, the implementation part, or the results part?
okay. So here the dataset that I have used, the student dataset that have these fields given, and by after find out the accuracy, I find out that the accuracy score of
Just a couple of previous slide. Just a
yes,
couple of previous slide, and from there you have two slides back. It will
yeah,
have a better clarity. Yeah.
yes. This is the confusion matrix that I have get uh, from the uh, from the code that I have run. And here I have get the true positive value, true negative value, false positive, false negative value, and based on this we can predict the accuracy. So I have also the code with me, so I'll show you. And this is the result part. Here the classification report of KNN. So the accuracy score of KNN is by using the class 58%, but if we use the K-fold method, the accuracy score is going around like 52% in case of KNN. In case of logistic regression, the accuracy score is 67%, but using K-fold, the accuracy score is 57%. I have used multiple algorithm here. In case of NaveBase, it is 68%, but using K-fold also it is 68%. Why are using K-fold? Because it will split the dataset into multiple set and then extract the value. That is why I have also checked that by using the K-fold, the result is also giving, may the result give some different value or not. So in case of decision tree, the accuracy score was 65%, and by using K-fold, the score is like 56%. And random forest gives 65% accuracy by using K-fold, 67%. Support vector machine gives 70% accuracy by using K-fold, it gives the 60% accuracy. And here I have the code. I can show you. This is the heat map that shows that there is no null value right now. And this is the pair plot given. And this is the confusion matrix that I have get from the after doing the k nearest neighbor. So the confusion matrix will show the true positive, true negative value. And from this confusion matrix, we can calculate the accuracy score, which is like 50%. But by, sorry. But by using K-fold method, the accuracy score is like approximately 52%. So here the I have also do this for the others model also, like logistic regression, support vector machine, random forest, decision tree.
So, Deepta, I cannot see this classification report clearly. It's not at all visible to me. So, it's just a
Okay,
suggestion to
sorry. I
improve the
have not
font
shared
size.
the tag. Okay,
It's
sorry.
in paper,
It's
right?
not in presentation mode even.
Yes. I've shared this.
So, anyway, you can continue with that
Ma'am,
and finish it off.
is it
Yeah.
visible?
Uh,
Is
yeah.
it visible?
Yeah, it is. I mean, the
Yes.
results. Yeah, the screen.
Yes.
So, you can
This
move on to the presentation, no problem at all.
okay.
There is some obstacle. Please remove it. It not
Sir,
now.
abstract I have said in the early section. Here is the abstract.
No, abstract not. There is an obstacle.
Sir
Okay,
is
it's all
saying
right.
something else. It's okay.
Conclude,
Okay.
please.
Okay. So, in conclusion, I can say that this approach proves that data-driven educational system can improve the student performance, their outcomes, and it will also can reduce the dropout rate and support them through as well as their in case of decision making, as well as their in case of academic decision, and it transform the raw student data into meaningful insight so that it can enhance decision making strategy, and the use of machine learning helps in personalizing learning experience based on student strength, weakness, their learning style. So the futures could include that the use of these advanced AI models, real-time learning, so adaptive learning. By using this adaptive learning technique, we can improve the student performance and their outcome, and in real life also. Actually. So thank you.
Is it done,
There
Sudipta?
are no
Yes,
questions.
ma'am. Thank you. I'm
Yeah.
concluding.
So, yeah. So my only question to you is, why have you chosen classification method for your work?
Because here the data set that I am using, it is gives the output like on classification, like either they will pass or fail. Then I have to choose the classification method only. I cannot use here the regression.
Okay. All the best. Thank you.
So with that, we conclude today's paper presentation session at Night TEAS. We sincerely thank all our presenters for their valuable contributions and our audience for their active participation. Once again, a special thanks to our session chair for guiding the discussion with clarity and depth. I would like to present the certificates of our session chairs. So, um, yeah. Thank you so much, sir, for joining us today. And mm, thank you so much, ma'am, for joining us today as well. I would also like to request all participants to kindly switch on their cameras as we are gonna take a virtual photograph to capture the memorable moments. So please, I request everyone to turn off their cameras, turn on their cameras. Mm. All right. Thank you all, and we look forward to seeing you in the next session. Have a great day ahead. Thank you so much.